I am Senior Manager at Indian Oil Corporation Limited, and I will be presenting the challenges and how we have resolved at site during laying of offshore pipeline, which was a project undertaken at Wadinar in Gujarat for replacement of our existing offshore facilities, which Indian Oil installed way back in 1978. So, I will start my presentation with a quote of our first Prime Minister of India that oil is of vast importance in the world, and a country that does not have its own oil is in a weak position. And accordingly, we can see that today in India we have 23 refineries, and we are not dependent on for our oil products. Although we are importing crude oil, but we have our own refineries for the products which we are using in various aspects of our life. Nevertheless, India is the third largest energy consumer as well as the crude oil importer, whereas the fourth largest refining capacity India is having at present. So, if we look at the brief outlook of crude oil import in India, so we can see that around 90% of crude oil requirement of India is taken care through import. So let us see how these imports are taking place. And one more thing, that all these imports which we are doing right now is going to increase, because the as our Prime Minister has said, the target of 450 million metric ton of India refining capacity in next 2 decades. So these imports takes place at single point mooring system, which are installed along the coastline of India. And at present we have 27 single point mooring system, and most of these single point mooring systems are installed in Gulf of Kutch region, wherein Indian Oil installed its first single point mooring system. If we just see an overview of single point mooring system, a single point mooring system is a floating platform wherein a tanker can berth, and crude oil unloading can take place through this floating platform using hoses and offshore pipelines, and then it can be transferred to our tank farm location. So the first unloading SPM of India was installed by Indian Oil in 1978 in Gulf of Kutch, and that was installed to taking advantage of the shelter, natural shelter, which Gulf of Kutch is providing, so that the wind, current, and waves do not hamper our operation and maintenance as such. So, after serving 45 years to the country, these offshore assets were health assessment of these assets are being carried out regularly. And after serving 45 years, we had undertaken this offshore replacement project from September 22, and we have commissioned this in January 24. So this is a brief outline of the project, wherein we can see the existing two SPMs in red color, SPM 1 and SPM 2, and the new SPM locations, SPM N1 and SPM N2, from where two offshore pipelines were laid, and they were connected at Narara with the onshore pipelines. So, how we have undertaken this project? For that, the initial geophysical survey, by which we have fixed the locations of SPM and the route from these SPM till the landfall point. While selecting the location and of SPM and offshore pipeline, we have kept a few factors in mind, like the SPM should be 2 kilometers from each other. It should not have a long bending radius, and in the intertidal zone, the offshore pipelines spacing should be minimum so as to avoid minimum damage to the marine environment. And from the existing SPM, the offshore pipeline should be at least 450 meter, so that so as to avoid the clashing of anchor chains. So after selecting the SPM location, finalizing the SPM route, we had carried out the geotechnical survey, which we carry out in all other projects to finalize the design of our appurtenances, design of our offshore pipeline, thickness, and the diameter of SPM pile, anchor pile, plumb pile. So all these things were finalized based on the geotechnical survey. And in the following steps, we have executed the offshore pipeline, which include basically laying of offshore pipeline, and trenching, shore pulling, and laying through SLA method, and finally the tiny spool. And for installation of SPM, we have to do the anchor piling, plumb installation, and finally the installation of SPM buoy and its hookup. So laying of offshore pipeline is carried out in basically three phases. The first phase consists of the shore pulling, means the bars need at least 10 to 12 meter of water depth from where it can be stationed. And from there, so barge was stationed at this point where it is shown at the barge location. And from this point, the shore pulling was carried out using a winch which was installed at the landfall point. So upon completion of shore pulling, we carried out the SLA method, laid the pipeline through SLA method from barge location, which is shown in this picture, till the SPM location. And finally, a tiny spool was connected between the offshore pipeline and the plumb flange. So if we look at the intertidal location at Vadinar, it has a long 2.5 kilometer of intertidal zone, wherein the tides varies by 6 meter every 6 hour, 5 to 6 meter every hour. So this laying of offshore pipeline in intertidal zone was found very challenging and difficult. And my presentation basically will be covering how we have tackled all the challenges. So if we see the challenges which are there is the presence of corals, then difficulty in plying of trenching spread, maintaining the trench in the varying current. Sometimes it was 1.5 to 2 knots, sometimes it was 3 knots. So it was very difficult to carry out the trenching and then maintaining the trench. And then during the shore pulling also, which I'll be presenting next in subsequent slides. So to take care of the marine environment, we had translocated the corals which were falling alongside our pipeline route through government agency Geological Survey of India. Then um, we have say for safeguarding our existing pipeline, we have demarcated the existing pipeline so that during the movement of trenching spread that doesn't damage our existing pipelines. Then to overcome the plying issues, how the trenching spread will be plying in this long 2.5 kilometer of trenching intertidal zone, we created a high raised platform. In the figures we can see excavator going on the this raised platform during the low tide, because every 6 hours this region will be filled with the water. So once it is filled with the water, this land based excavator cannot ply. And then during the same location during the high tide, we can see the excavator at this position. So suppose we would not have created such a platform, then every time these excavators has to come inside the landfall point, near landfall point, and then again go. So it is a wastage of time and means increase in the time and cost for the project. Similarly, as I said that the long intertidal zone and the high current was a challenge for maintaining the trench. So we have created bunds at different places so as to reduce the intensity of current. And we can see these currents which was also used for applying the excavator from one side of the trench to other side. Similarly, there was a region called subtidal zone. As I said that the barge need at least 10 to 12 meter. So at the subtidal zone, the water always remains at a depth of 4 to 5 meters, 6 meter. So at these locations, trenching was carried out using the spud barges, because land-based excavators cannot come, and at the same time, barge cannot come for carrying out the shore pulling. Then the problem was of soft soil. There was a varying soil condition in this region, and therefore we had to use the cutting section dredger for a stretch of around 450 meter from KP0 to KP0.45. So this loose soil conditions was resolved using the cutting section dredger and the mud mats. Then the after completion of the trenching, the next stage of offshore pipeline laying, as I said, was the shore pulling. So again, this 2.5 kilometer of long shore pulling was a very difficult task for us to execute. And at times you can see in the pictures that due to high current, this offshore pipeline used to come on the trench side. So again, posing a risk to pipeline, delaying the project, and overall, it was not a desirable condition. So what we did to resolve this issue, we created a vertical bailage alongside the offshore pipeline. For that, we removed the floating buoys which we have to install during shore pulling. Floating buoys are required because if we don't install the floating buoys, these offshore pipeline will touch the seabed, and during the shore pulling they will get damaged. So we install these offshore this floating buoy all along the length of the offshore pipeline. So we removed at certain places so as to minimize the effect of current, because once we will remove the floating buoy, some of the portion of the pipeline will go inside the trench, and then once it is inside the trench, there will not be effect of current. So the first offshore, there was two offshore pipelines. First offshore pipeline shore pulling was completed in 18 days to be precise. So after facing these difficulties and implementing this method, we carried out and completed the shore pulling of our next offshore pipeline in 10 days. Then during the SLA method, as we were using 42-inch pipeline having a wall thickness of 24 mm, so there was local buckling issues were there. Means the stress which was coming on the barge stinger was more than the allowable limit. So to resolve this issue, we again install these floating buoys, which we normally don't install for a SLA method. And then for stripping, we had installed a strip out arrangement over the barge only, so that diver doesn't need to go inside the sea and strip out these buoys. Then the third stage of laying is the installation of tiny spool. So normally for a tiny spool, we have to carry out the metrology, for which a diver needs to go inside the sea and take the measurement, bearing and distance between the two flanges of flame and the offshore pipeline. But normally it is a time consuming and not so accurate. So we introduced long baseline technology for this, wherein we install the transponders on both the flanges and other transponders at a certain distance. There was a receiver at the barge, and they were communicating with each other, so that we get the precise data which we require for fabrication of these spools. So with this method, we installed our spool successfully, and right now it is commissioned. So this way we overcame the challenges of offshore pipeline laying. So the next stage was installation of SPM, for which we need to install anchor pile. These are the photographs illustrating how anchor piles are installed, for which first we have to insert the casing, then we have to carry out the required drilling, then lowering of the pile, and then the grouting of the annular space between the drilled well and the pile. And these are the actual photographs how this drilling was carried out. So while carrying out the geotechnical survey, we found the varying soil data at our region and one BH11 bore number. So there you can see very loose soil. For that, and then there was varying soil condition at different bore locations also, and accordingly the design of casing pile was carried out. But during execution, we found that it is not 100% matching with the design. So we had to modify the length of casing by carrying out our own survey from time to time. And then for BH11, wherein the soil condition was not very good, we have to use a modified pile which was having a non-uniform thickness. The other piles were having a wall thickness of 50 mm all through along its length, whereas for this pile we used a varying thickness to take care of the lateral means capacity of the pile. And after installation of these piles, we installed successfully our pipeline end manifold. And then yes, the backfilling was, which was the last stage of this project, was again a challenging in terms of that we this foreign material is not required to be backfilled inside the trench because of the eco sensitive issues. So we segregated the existing material which were available, which we had taken out from the trench. We segregated those materials, and then we backfilled the trench with those materials only. So we were complying with the engineering requirement as well as the environmental requirement. So this project, to summarize, this project was a very mega project of Indian Oil for replacement of this offshore pipeline, which are catering to our three refineries, and we all are dependent on import at present. 90% of our crude oil requirement is meeting with the import only, and as we have solved our problem with our in-house method, in-house techniques, so we all can solve with mutual cooperation. So thank you.
For taking us through the experience sharing, and you had pictures and videos which made us think that we are actually experiencing the challenges that you faced while executing this project. Now our next speaker will be talking about maintaining those assets which you had constructed. So I am requesting Ms. Nivedita Sharma Bhattacharya. She is General Manager, Specialist Materials and Maintenance Engineers India Limited. And her topic is maintaining structural integrity of carbon and stainless steel pipe inside oil and LPG rock caverns for entire design life. Please.
And good afternoon to everyone. Uh, Actually, in my topics, in the previous section, there are two speakers has already explained what is Kavan and all. So I'll not take much time for this, what is Kavan and all, but I'll speak about the how to protect the, structure inside the Kavan for the entire design life. That is almost 50 years, 50 to 60 years. That is a challenging of this, projects. Yeah, so India began storing strategic oil reserve in underground rocks cavern since 2008 to secure energy resource, a move crucial for national energy security. So this rock cavern must meet stringent geological and rock stress requirement, and particularly the low permeability and stability, and which make them ideal for long-term LPG storage. So I'm going to talk about the LPG storage. It is almost similar like oil, but there is a difference in the protection level in this LPG cavern. What EIL actually has done. So this is overall schematic drawing. There is already in the two sections. Actually, those who have attended, they must be knowing. So I am just just importance part is here is shaft. So that is also mentioned. This is shaft person. Shaft area is important to protect the pipe because these other parts are all rocks and LPG is inside. So there is no corrosion. As rightly said Mr. Ajay, who has explained that there is no corrosion inside the LPG, inside the any cavern, but yes, corrosion is there inside the shaft, where water will be there, water or many other things like soil is also sometimes it may go inside. So there are 17 numbers of carbon steel and stainless steel duplex pipes in my in these projects. Like there's a case studies what we're doing. Then for filling and discharging LPG lines, the carbon lifespan is, as I said, just 50 years. So we have to ensure the structural integrity to maintain this for 50 years of design life. So a hybrid cathodic protection system was installed. I'm going to explain how it has been done. So why corrosion is occurs and what are the requirements? What is the novelty of this? These projects like what has done. So pipes are used in rocks common for transportation, ventilation, and evacuation. So the SS penetrates through the soil and rock layers to reach the bedrock, and pipes are mainly of carbon steel and stainless steel. So what is corrosion? As we know, in our childhood chemistry also we have seen that corrosion occurs when the electrons leaves from the anodic area and cathode is taking the electrons. So this is the phenomenon is going on when there will be four elements like anode, cathode, and conductive electrolytes and metallic path. There are four items as is there, so corrosion will happen. So in this inside the cavern, this is happening. Severe corrosion occur because differential oxygen level in the inside the cavern, then constant oxygen concentration, then MIC microbial in this corrosion where less of oxygen is there. So as in the offshore structure, when the when the bedrock, so there will be less oxygen, so MIC is there. So then aqueous electrochemical reactions, so different material and metallurgy, because if stainless steel carboxylate is there, so there will be differential potential in the Gibbs free energy, as you know. So definitely carbon steel will be corroded. So we have to protect both the pipes and at various depth. And CP system installation is a challenging task in a limited space and different depth at bottom of the shaft. So replacement of the pipe is also not possible once it is installed inside the cavern. So and pipeline with coating, yes, it can be done by the primary protection, but in coating defect, so that is called we holiday, just like in the pipeline, buried pipeline. So that has to be, it's implemented by the CP system. If CP system is not there, then there will be pitting corrosion will be start occurring, or various corrosions may occur also. Like I explained, like MIC and other ocean corrosions. So why corrosion protection is required? What is preserve assets and provide safety, then reduce maintenance cost, inspection cost, then company government regulation, preserve environment. So GDP of India in 2022, as per the impact study of NES USA, now it is called AMPP, Association of Material Performance, Material Protection and Performance, that is in 3.38 trillion US dollar, and 4.2% of GDP we are losing because of the corrosion. That is almost 11.8 lakhs crores, which is a huge amount we are actually losing. In India is losing. So we have to be very much concerned about our to asset our to protect our assets. So estimated worldwide cost of corrosion is 2.5 trillion US dollar, and it is 3.4% of GDP of industrialized countries. So that is also a very big amount. But India itself is a big amount. So we have to be concerned about to protect our assets. So why CP is inside cavern shaft? That I have already explained. That first, line of defense is your protective coating. Then it is supplemented with the cathodic protection system. Then potential measurement facility with the cavern. We can see what is going on inside the pipe and increase accordingly. We can accordingly we are increasing the lifespan of pipes. So what is cathodic protection? By virtue of cathodic protection, we can protect the pipes or any structure, stainless steel, carbon steel structure from the corrosion. And it is a technique which arrests all from corrosion, uniform attacks, galvanic, pitting, crevice corrosion, MIC, stress corrosion cracking, excepting hydrogen damage. Hydrogen embrittlement you cannot protect from corrosion because because of the material properties, carbon steel properties. So we have to be very careful while we are using the CP system. So it should not be some limit of potential we cannot increase. So I will not explain this much because this is not corrosion forum, but I am just touching these points. The most effective method of corrosion control bring corrosion rate to zero. So there are two types of CP system we have used, and cavern. So above the concrete plug, this is the Empress current CP system, while using the power system and electrons releasing from the anodes, and where in the concrete, below the concrete plug, below the concrete plug is a sacrificial type. There is no power supply. So material itself is a consumed. So you can understand very easily in this picture. So ICCP system for above plug, and plug level is a concrete slab where there is the LPG will be below the plug level with water, mixing of water, and above plug level will be all water. So then the sacrificial error system for beaver is provided. Then sacrificial zinc anode, actually what we are using zinc is the best suitable anodes for using zinc anodes for 15 tons of zinc anode as per our calculation and as per experience. Then before various studies and everything. So we have taken 15 tons. We have installed 15 tons of which is a very challenging you can say installation method, because it's a very limited space. It's a very dark and water is also inside. So we have done this. Then this is a scheme actually. So how we have gone, how we have installed on the bottom of the plug. Then see, SAP validation also we have done, provide a software modeling. This is the this 10-meter depth up to from the bottom of this plug level. This is a 10-meter depth we are protecting by sacrificial anode, and above the plug level almost 109 by 109 meter we are protecting by ICCP system. The system validation we have done. This is protecting. Yes, all the green, blue, and green color we are protecting. Red color is the unprotected area. So yeah, so this is the anode. This is the anode installation inside the covered SAP system, sacrificial anode system, bottom of the plug. And this is we are taking the measurement of the nasal PSP. And this again after the installation of CP we are getting the result. So now coming to the above portion of the plug point, that is a amperescan CP system. There's a 94 numbers of anode with 2 CP units, 2 transformer rectifier unit, power supply unit we have installed. One is standby definitely. So one is by one we are using. Then coating is a glass plate coating was there in some carbon steels, and there are 2 stainless steel pipes are there in the water lines basically. So this is the scheme. I am showing how we have done the impressed and CP system on the above plugs, plug levels on the 17 numbers of carbon steel, including the stainless steel, duplex stainless steels. So the design parameter we have maintained as per the NES, MPP, DNB, ISO standards with respect to silver chloride reference cell. Then ICCP system software modeling also done. Yes, we have got the result from +4 elevation to -109 to the bottom to the plug level. So this is the system. Some portion it is coming, in the range itself. It is coming through the modeling, software modeling. The protection level was there. So all this, so elevation wise, I am showing you this protection level. Yeah. So what you have done is a key innovation in this project. This project represented a first ever deployment of cathodic protection for casing pipe inside a shaft designed for LPG command in India. The hybrid system combines sacrificial and impressed method to meet the unique design requirement and ensure longevity in a highly corrosive environment. And because we know this is coastal area, all carbons near the coastal area, chloride level is very, very high. So we are protecting the pipes. And this is a specially designed system, provide uniform current distribution. This is a major design concern, how you are going to CP current distribution. It should not be a shielding effect for the pipe, because it's a very, very congested area where you are going to install. And this is a robust system, safe and is reliable, and these trucks are reducing the chances of corrosions, and we are confident to monitoring. We are confident because we are monitoring this facility CP system and this protection level. The using the reference sample will give the information, critical information of the integrity of the structure. Yeah, so finally, so the CP system ensured that the LPG covered casing pipes will be safeguarded from water side corrosion, meeting the project's 50-year design life of acceptancy. And then combination of zinc sacrificial anode and impressed current CP system enhance the durability of the pipe infrastructure, making this an innovative and crucial project in India's energy storage capabilities. Thank you so much. So any questions? I have the time for 2 point, I think time is there for 2 minutes. I can.
Any questions if anybody wants to ask? The speaker had given you an option. So no questions. Thank you so much. I think you were well understood.
Thank you, sir. Thank you all. Yeah.
Thank you. Thank you, Nivedita, for this exceptional presentation where you have told us the method of preserving the pipelines for a long period of time. 50 years is a long period, certainly very long. I won't be alive till the replacement of that anode is required. So with that, we are coming to another presentation. Again, it is on the corrosion protection. by Rituraj Mishra, who is the Chief Manager in Pipeline Projects of Bharat Petroleum Corporation Limited. He will be presenting on the topic of enhancing life and reliability of smart gas transportation assets, corrosion analytics. Welcome him.
Yeah, good afternoon, everyone, and energized afternoon to all of you, because corrosion is all about metals going back to their mother state, and what we enjoy is energy. So I need an energized audience so that we can prevent corrosion. That's what is expected from you all. Thank you. So as we move to the topic, we believe that the time has come that we move into effective corrosion monitoring, because we create systems, but unless you monitor them, you are not sure whether the systems they are designed for are doing the purpose. So I will start with a small poem that we have created. Rust is must. We can measure it, we can test it, we can halt it, arrest it. We can gather it, weigh it, we can coat it, spray it, we can pick it, we can drop it. We cathodically protect it with a strong belief, and that belief is we can stop it. With that belief, I take you all to the world where corrosion is never for maintenance. Don't take pride in saying that. Let's prevent it. That's more important. So the question arises is, do you really monitor for corrosion for data? So the time is now we monitor for evaluation of that data and extract information that can help you with a decision. That's the purpose of monitoring. So having said that, we all take pride in saying having effective or efficient. So let's see about an efficient corrosion monitoring team. So you remember these three people? Corrosion, oh, these three symbolizes, that's it, summarized. We don't want this to happen. Okay, if you cannot withstand it, that does not mean it does not remain. Okay, so let's go into the system that we have created. We need to execute SIP in corrosion mitigation. We need from shift from data to information and enhance the numbers. We are all manpower, we are all capacity. We need to become capability for our organization. And finally, we need to transit from being efficient to being effective. So I will not go into the index. Well, success is all about forcing failure. And failures don't happen overnight. Corrosion also does not happen overnight. It takes years altogether to fail. Indicators have to be tracked at the right time. What is happening now is, until a crisis arrives, we are all happy, saying gaga about our work. The day it arrives, we're in firefighting, and again we go back to the same state. So we need to be proactive. So why there is a need for monitoring? There are assets which are prone to corrosion. We have to sustain it for the future. And then we need to analyze the relation of different processes that we keep on changing in our facilities and how they're interacting with the environment which is around it. So how do we monitor that? Yes. So here is a model which has been designed with the complete focus on input to impact. You have lot of files, lot of data in your laptop, desktop, hard disk. Those inputs can be cumulatively created into an impactful decision. With that theme in mind, we have created this approach. We went through series of data in the field. We did a lot of analysis and brainstorming, and then we arrived at this model, which is called the BPC Catho Pro. What is this model all about? Let's go into the details. We have a cathodic protection monitoring which is direct, which is online coming into our SCADA. We have a direct offline, which is taken by our technicians who go in the field, take the measurements, and then submit a report. Similarly, we have internal corrosion monitoring for the assets, again online, offline. So these are the four key measures which need to be controlled. Now, having said that, what is corrosion rate? It's all about your rate of a vehicle moving on the road. So it's in terms of corrosion, it is mm per year. And if you convert that into the velocity, it's like the kilometer per hour. What does matter for us is not the rate of corrosion. What triggers us is the acceleration. It's we human who are responsible for accelerating the corrosion. Corrosion is a natural phenomenon. It is bound to happen. Having said that, what we have done in this package is basically we have identified the critical components, the parameters, the measurement of the location where it can happen. We can predict the remaining life of the assets, identify their failure mechanisms in the future, and the fitness for service assessment. Then, with our experience of last 25 to 30 years, we have listed down the points which are normally ignored during your plant walkarounds or visit to your facilities. And those points are basically abandoned with time and finally end up leaking someday. And the consequences of a leak, you get published in all newspapers. That's what we deal with. These are some common mistakes that we do, not intentionally, but by negligence. They are not supposed to be like this. And we see it day in, day out, just ignoring. That's what is happening. And one day it shows its power. So here I present to you the BPC Catho Pro. I'll just tell you the background. It's a complete model created in-house with various programming tools. And this is driven by a simple framework of Power BI and Excel, wherein we can configure all our requirements and the output is completely based on the analytics. Just to give you an example. Now, PNGRB is there, OSD is there, and lot ASME and lot of codes are there. They all talk about monitoring. What we focused is 54 parameters which actually give you impactful results if you do monitor them, rather than just focusing on 2-3 parameters. So what we did, on the left hand side, we have listed down all the parameters. The best part here is the right hand side, the analysis column. It cannot be typed, it cannot be manipulated. It is fed from the programming which is running on the background. All these technicians and manpower is doing is basically feeding the readings, the column which is below the panel meter and external meter. They can only feed the readings go in the run in the program, and real-time output is generated on the analysis window. So the window itself is self telling you that yes, this is what you have to do. This is what is abnormal. Just to summarize you one report. If you see this report, you have just put the numbers in the column. The right hand side is automatically telling you what has gone wrong, how to mitigate it, whether it's normal or abnormal. It's all driven into the program which is running on the background. And the best part about these things is this is all coming on live. Just imagine one technician is taking readings 100, 200, 1000 kilometers away from Delhi. You are sitting in the office. The moment he pitches the readings in this software, the results are cumulatively generated then and there on the site, and it is relayed real-time basis to the mobile application of that engineer. And he is also watching the readings. So if any mitigation is required at that particular time, he can just make a call to the team which is there on the site, rather than waiting for 1.5 months to get a complete printed, analyzed report. Because that 1.5 months, corrosion never stopped. It kept on. So that is the intention of creating this. We have, as I told, more than 54 parameters have been configured, and they have been time tested. And these parameters have really helped us in generating a lot of proactive maintenance. Failures have been almost eliminated. And the best part is the service visit or breakdown visits are no more there. So that's how this has helped us, because the failures are very costly in the field of corrosion. These are few more things which I wanted to showcase. For everything we have created analytics, and that is working. So this is what I wanted to show. Now, having said this, the benefits of this module is real-time report generation for swift decision making, self-updation of data from the field to avoid any transit losses. Just imagine technician has taken the readings, went in the rain, in the sun, and lost that notebook or get wet in the rain. The readings is gone. Either you will create a manipulated data or get it lost. So those things are no more valid in this. So there is no separate mobilization required for breakdown visits, because you are real-time analyzing the defects. Officer is real-time involved with the measurements which are happening 1000 kilometers away. And there is a complete data bank which can be directly promulgated into graphs. You don't need to create, compile everything in Excel and then sit on that. Automatically trending happens on that. And I told about internal corrosion monitoring. Similar type of model has been created. The key parameters that we are doing, we have mentioned on the left hand side, and the effectiveness is based on the various parameters we have listed on the right hand side. So what are the key takeaways? The first thing is corrosion management calls for effective monitoring and evaluation of the relevant parameters. Just don't go in the field and take something which is easily doable. Relevant parameters help you to get a decision which is impactful. Otherwise, it has no meaning. For effective corrosion control, it is important to understand where, when, and why corrosion can happen. That is more important. The best part today is, today we are talking about new energy, renewable energy, and lot of different types of, in fact, hydrogen is pulling us like anything. But the assets which are there buried, let me give an example of pipelines. They are designed for certain process fluids or gas. You change the process fluid, but the impact of that change on the body of that metal has to be analyzed, otherwise it will be detrimental. Hydrogen has a big trouble. It moves across the walls of the metal because it is polar molecule. So one more thing, today India is growing at a big speed. Infrastructure is developing like anything. We are proud. It's a great threat to the buried networks and utilities, let it be any service provider. So this common ROU, wherein multiple service providers have laid their utilities, one damage can caterpillar and it may create a big hazard. So that's how important it has become. And the last one I would like to suggest is, in nowadays lot of facilities go into maintenance, shut down, and it takes 2-3 months. So those lines get dead or no flow or zero flow. Stagnant fluid is there inside it. And if it continues like that, those lines will leak out in very soon. Okay? So now is the time that we integrate data to deliver information, to add value to the initiatives that can translate into effective corrosion management. I'm grateful to certain journals that I could refer, and the rest all is the field work that I could do, and we could create a good model which is giving us relevant results, and we are proudly vouching for it. Thank you for your time, and I believe predictive analytics and management of corrosion can save lives at first, and then save money, maintain production, conserve the asset, and conserve the environment. Thank you for your time. Have a nice afternoon.
Thank you, Rituraj, for your entertaining presentation. I think we can take questions at the end, if any. With my experience, I see all audience are enlightened and require no further information. Now, this was an entertaining presentation. Technology is mostly boring, but I could see Rituraj starting with a poem and varying in the pitch of his presentation so as to make it so interesting. Thank you so much. Now I am inviting Dr. Gurmeet Singh.
So before we start, while I was sitting over here, a knowledge struck me why drag reducing agent is important. Uh, Over here, when we are sitting, uh, we are sharing our knowledge with you. So we are delivering and you are receiving. So similar way, the pipeline operations also work. We are pumping and say a refinery is receiving all those crude, or a terminal is receiving, for example, the gasoline or the diesel. The problem can be due to chaos, similar to this particular station we are sitting. Every alternate minute or so, aeroplane is crossing, public announcements are being made, so much of ambient noises there. Probably a chiller is running on your right hand side, which is creating its own noise. So the people who are delivering the knowledge, they will have to put more energy into it. And if you have to gain that knowledge, you will have to put more energy to keep you focused on what we are discussing. And DRS work like maybe they will give a acoustic curtain to this particular venue so that the exchange of information between the speakers and the listeners is much more efficient. So what exactly the DRS do is increase the efficiency of the pipeline operations. Again, I have already explained you the challenges, all efficiency. And today, the sustainability is a buzzword, and not only buzzword, it is a essential for even human survival. India is, we have got India is one of the largest, we can say, pipeline operators. The pipelines are crisscrossing almost from north to east, east to west. So huge, we are running maybe many thousands, tens of thousands of kilometers of pipeline, which are pumping crude oil, which are pumping petrol and diesel. So and this is the scenario. And the challenge is again how efficient we can deliver our goods across that pipeline, like we are delivering or exchanging our knowledge. And again, we have to organize when what we are delivering. On the right hand side of the presentation, I've shown a picture on which a few vehicles are running in their own lanes, which we can say we can see the flow is very streamlined. And in the pipeline, again, what happens is after a certain flow rates, the flow becomes so chaotic that the molecules don't know where to move, so they start to move in a chaotic or a random manner, similar to the acoustics of this particular setting. So what pipeliners do, we inject drag reducing agent into the pipeline operations, and these drag reducing agents contain a little bit of polymers which are ultra high molecular weight polyolefins, and they are unlike any typical commodity polymers which we use. For example, even this controller is made up of plastic which will have molecular weight typically of 2.5 lakh. What now we are talking about is a product with having molecular weight of say 2 crores or so, 20 million. So now we are not talking about small increment, but we are talking about a quantum jump to the tune of magnitude, which is 100 or so. And these molecules, what we synthesize, are depicted on the lower side of that the slide, which is a comb-like structure. So these are ultra-long chains with certain pendant groups hanging. And what they do is they streamline the flow of liquid when we are transporting, and it works across petrol, gasoline. It works for diesel. It works for different type of crude oils as well. And this is the journey when we have undertaken to develop the complete process. First, we started to develop with the catalyst. Uh, to produce such a high molecular weight polyolefins is not a very easy task. It takes a lot of efforts to go to do that. In second case, we did the polymerization process development. After we have undertaken the catalyst, so now we wanted to have the right polymer to go with the right architecture of a comb-like structure that we did, and then thousands of experiments were done to establish the repeatability and the reproducibility of whatever we are doing it. Then we got our product evaluated at a third party in Germany. That was till the journey till polymer. Then we made a formulation so that our pipeliners friends, they can inject that DRA into their pipelines to make it a usable product. After that, we undertook two commercial trials in IOCL pipelines. Thanks to our pipeline division, they were very eager and they supported us across our all this development journey. And then the day came in 2021 when we commercialized and we licensed our technology to our partners, Dovpital. A representative of Dovpital is also sitting within the audience. And then there was no looking back. This product is which is proudly made in India and now being produced in India and being used by all our pipeliners. And the technology is not a very easy technology. It is a very complicated technology. And before we entered into the production, handful of companies were producing and selling this product. And most of the companies what were producing or when we are IOS, Indian pipeliners were buying was all based in USA. Every aspect of the technology was closely guarded, highly patented. So when we started the project, then the challenges were extremely high. So then there were a lot of apprehensions also from all the different, we can say the different partners towards the journey of this thing. the catalyst itself was a very challenging. Then designing a process with which we can make that particular polymer with a certain architecture with molecular weights ranging, say, 20 million daltons was a very uphill task. So, and that was never done in India prior to that one. And while doing so, we did that thing. So that polymer, then again, it is not a usable polymer as such. So then we developed a process to convert that polymer into a product which our pipeliners can buy and consume in their pipeline operations. So it involves the technology development from the in-situ technology development. We started from the scratch till the final product, which was usable in the pipeline operations. So the technology is now well commercialized, well proven, and the different aspects of the technologies are it enhances the flow rate. So at the same energy consumption, we can push much more liquid through the same pipeline. Uh, so it enhances the throughput indirectly. Or if we have to keep the same throughput, we can reduce the pump pressures. So the pipelines can be operated at lower pump pressures, which also means that even the old derated pipelines can continue to be in operations to push that liquid. It has resulted in significant energy savings, not only for IOCL, but all other customers, including HPCL, BPCL, HMEL, all are using at present the our extra flow DRA. That is the our patented or trademark name for our this particular product. So this is a innovative solution for pipeline flow and efficiency. And the what gives us the maximum pride is a technology which was never heard or can be which was only in control by a handful of players sitting in USA. We did it in India and we proved it through extensive trials and through commercial adoption by all the pipeliners. So this is the data where it proves that the efficacy of our DRA across the crude pipelines in different sections. So it worked. The dosages rates can vary, say, from 4 to 20 BPM, and the drag reduction is also is not directly proportional, but it will depend upon the hydrodynamics of that particular pipeline. So it has been proven on for the product pipelines, the crude pipelines across different geographies, across different, say, elevations and other complexities. And as we speak now, we licensed this technology to our partner, Doffmittel, in March 21. So working very closely with them, by September 21, already the commercial production started. And November 21, the commercial supplies regular commercial supplies were being made by our partners, Doffmittel. Prior to introduction of the drag reducing agent by IOCL, 100% product was imported. And in 24-25, other than a very small shipment coming in India, rest all the product what is being consumed by all the pipeliners, be it public sector or by private sector, is proudly made in India. And not only that, the value what this product has been able to offer to customers has resulted in increase in year over year adoption by our pipeliners. For example, when we entered in 2021, the consumption was around 980 KL in that particular area, in that particular year, sorry. We entered into the market somewhere in November 21. So effect was very apparent in the next financial year, which is 22, 22, 23, 21, 22, and then in 22, 23, the market penetration increased further. The imports, they reduced drastically from 100% in 2021 to only 18.4% in 2024. Not only the imports are reduced, but the consumption by Indian pipelines also increased. So that is the beauty of if we make certain product in India, and if we offer that product of the highest global quality at the right cost, then it fetches much more value for all the organizations. And as if we talk about as a country, every pipeliners has benefited from this particular product. And prior to this, I should not be taking the names, but the import figures are on the right hand side of this graph, and you can see that now the particular bar graph of green is increasing year over year. And but in this particular financial year, it will be all our product which is being sold in Indian market. So it has given us the first mover advantage. It has commercialized product. It has we have got number of patents across different jurisdictions. So it is a proven solution. And as I speak, so other than IOCL, which happens to be my parent company, BPCL, HPCL, HMEL pipeline are all using our product. And when we started, another interesting perspective to this particular project is that when we started, we were expecting the market to be around 2000 KL or so, probably by 2025. And in 2025, already we have sold more than 2500 KL product. So the adoption by Indian pipeliners is increasing just because we are offering much more value to our organization, to all the organization. And this has enabled significant energy savings to all the pipeliners. This data is particular to IOCL, what we get from our pipeline colleagues. So during 23-24 itself, 78% product of IOCL across crude and products was transported using in-house DRA, IOCL's own DRA, which and throughput enhancement is to the tune of 20%. So we estimated how much cost we saved on energy, and it comes to be north of 100 crore rupees per annum. Similar product quantities we have sold to our other pipeliners also. So it means India as a nation would have saved more than 200 crore rupees on energy itself by adoption of extra flow DRF product. And other than that, another significant is around, we estimated how much CO2 reduction we were able to achieve, and that was around 57,000 tons. And so now this is one major figure. Many companies are talking about sustainability and how we are going to do it. This is one product which is already making that thing happen. So now we are not talking about tales, but this is a sort of story which is true, and it is happening right now. Another proud feeling is that all of us who are visiting IEW and whosoever has traveled by a car driven by either gasoline or diesel is we should be thankful to our IOCL DRA product. It will have a reflection of extra flow DRA. Either it is gasoline, either it's crude or petrol. Yes, this is our product which is making it happen. And as we move ahead, we are now looking forward to explore exports. Already trials have been conducted in Middle East. Results are very encouraging. Plant audit has been completed, and approvals are at advanced stage, and we expect orders to be received soon. Uh, and looking still forward, we are now trying to develop more products. We are trying to develop other products which will give much more value to all of our pipeliner friends. So we are working to how to further reduce the cost. In any case, if our product is much more cheaper than what we have been, India has been importing, say, for example, 3 years back. But still, we are working how to further add value to that product so that the adoption further increases and India as a nation can gain from it. And I'm thankful to all our pipeliner friends who have adopted this product. And this is a proud picture which I can show you. A truck is loaded with our DRF product and ready to be dispatched across different locations of pipeline in India. Thank you.
Thank you so much, Dr. Gurmeet, for this splendid presentation on the indigenization of a technology. Not only technology development, but commercialization. Such stories are rare, where a product developed and then it replaced the entire import of that particular product. So kudos to you for this wonderful presentation. And now we come to the end of our session. I would ask the audience if they have any questions, they can raise their hands and ask the panelists. If there are no questions, then I will proceed with final thanks. Thanks to Vikash, Nivedita, Rituraj and Dr. Gurmeet for being wonderful speakers. And I, as a host, I forgot to tell you the timelines, but I could see nobody hit the final alarm. So you could complete your presentation before time. and the entire session is on time. We had a wonderful session where we started with the construction project where there was an experience sharing on an SPM, which was a wonderful, challenging project. Then we went on to uh, find out the methods of saving our assets through corrosion protection. Two presentations were on that. And then operationalization, DRA. I think this was a wonderful session where we had a gamut of a diverse panel of speakers who enriched us. And final thanks to our audience who have been patiently listening to us and very attentive. Not last but not the least, the organizers who have made this wonderful arrangement. Thank you so much.